Welcome to another new video on unsymmetrical bending. In this video, we will be solving a numerical problem related to rectangular section subjected to unsymmetrical bending. That represents case 1 of unsymmetrical bending, right? So here let me talk about the rectangular section which is subjected to symmetrical bending. That means the load is acting along the centroidal axis. Let me say the centroidal axis are xx and yy, and the load is, imagine the load is W acting along y axis. So if you see the bending profile, that will be exactly like this, right? That is known as symmetrical bending. And here, imagine the load is acting inclined. The load is not acting along centroidal axis and it is inclined. Then what will happen? The bending profile may be like this. So we have to find out stresses in this type of bending, which is known as unsymmetrical bending for the symmetrical section. Case 1, example 1, rectangular section. And before going into that, see, let us recall where you see this kind of loading and this type of beams. If you see the roofs, so which are subjected on beams and columns, so you may see the roofs which are subjected to this kind of loading. So there are many examples you can see in civil engineering structures. If you, whenever you come across this type of loading, please remember this concept of unsymmetrical bending. So let us see two cases of unsymmetrical bending. What is the first case we have talked about is section is symmetric like rectangle and the load line is not along or parallel to the centroidal axis. That means load is inclined. Second case is section is unsymmetrical and the load line is along parallel to any centroidal axis. As you have seen previously in angle section and the load is acting along y axis or any axis, the bending will be like this, maybe like this. Bending profile will be, so it is subjected to unsymmetrical bending and it is creating a new set of axes for reference as a bending, right? So that is second case. We shall see that in coming videos. As of now, let us see the first case, first example, rectangular section, and we shall solve a problem related to that. So this is the question. Calculate the stresses at the corners of rectangular section of a simply supported beam of span 5 meters which carries a load of 4 kilonewton at the center of the span. The load line is inclined at an angle 30 degrees to the vertical longitudinal plane as shown in the figure. Sorry, I forgot. So this is, in this way the load is acting at 30 degrees. This is the load, how much, 4 kilonewton is acting, and passes through the centroid of the section, passes through G. The dimensions of the section are given in the figure, and this is the breadth we have 40 mm and the depth we have 50 mm. So this is the section we have. We need to find out what are the stresses that will be developing at every corner, each corner, due to this inclined load, right? Due to this unsymmetrical bending, how the stresses will be developed, we have to see now. So let us see the data which was available. So here breadth we have, breadth of the section B is equal to 40 mm, depth we have, 50 mm, right? And length of the span is given as 5 meters. Let me take all the parameters in mm. We have distance and forces here, force or load. So let me take load into Newton and distance as mm. So it can be considered as 5000 mm. 1 meter is 1000 millimeters. W is 4 kilonewton, that is 4000 Newton. And let me come back. Sorry, angle is given as 30 degrees. Okay, let me now come back. Here, the rectangular section of simply supported beam. This is a simply supported beam and span of 5 meters. It is having the length 5 meters. So let me say length, and it is carrying 4 kilonewton at the center of the span like this. So what will be the maximum bending moment here? Maximum bending moment for simply supported beam carrying point load at the center or concentrated load at the center, that will be W into L by 4. That is what you have seen in the previous semester, right? So let me calculate what is that. The load we have 4000 Newton multiplied by length 5000 millimeters by 4. So that will be 5 into 10 power 6 Newton mm. Force multiplied by distance is the moment. So this is Newton meter, Newton mm. Newton mm is a are the units. Please do not forget the units. So in order to find out the bending moment, in the previous video we have, that is m cos theta by a xx into y plus m sin theta by iyy into x. So let me quickly recall how I got this. So we have the bending equation, right? Sigma by y is equal to, sorry, m by I is equal to sigma by y is equal to e by r. Let me take these two. Sigma will be m by I into y. So where there we have seen moment of inertia about x-axis for this, all the similar type of loadings we have seen, and length is we have taken perpendicular to the x-axis. That is y distance. So now let me say here m is a moment, m cos theta, because what we why I have taken cos theta is the moment which is inclined will be resolved into two components. Here see, this is inclined, so when the load is acting along this line, moment is also acting along that line. So now this will be m along, this is y axis, this is x axis, this is my, this is mx. So now let me take this as right angle triangle. So this is 30 degrees, this is m, what already we have, this is my, and this mx I am drawing it here in order to form the right angle triangle. So in that, opposite side is this, adjacent side hypotenuse. So sin theta will be adjacent, sorry, opposite side by hypotenuse. What is opposite side here? Mx. Mx by hypotenuse is m. So mx will be m cos theta. Sorry, m sin theta. So this is m sin theta. And if you take cos theta, that is adjacent side by hypotenuse. So that will be, you will get it as m cos theta. So that is already we have seen. So in that manner, m cos theta is here. M cos, what is m cos theta? This is m cos theta. M cos theta acting in this way, and it is trying to bend the beam like this. The bending profile may be like this. That means it is bending about x axis. So let us consider the moment of inertia about x axis multiplied by y coordinate, the distance from up to neutral axis, that is small y. Now m sin theta, this is trying to bend the beam like this in this manner about y-axis. So consider the moment of inertia about y-axis multiplied by the distance from the neutral axis, that is small x. Right? Let us now substitute all the parameters and let us find out what is sigma. Let me write it here. Sigma is equal to m cos theta by ixx into y plus m sin theta by iyy into x. This is what we have. So do we have all the parameters? Moment we have already calculated. Cos theta is 30 degrees. So y and x I will tell you how to find out. And here ixx and iyy we need. Moment of inertia about x axis for the rectangular section will be, as you know very well, bd cube by 12. That is, so breadth we have 40 mm and depth we have 50 mm. And this is here 40 into 50 cube by 12, and that will be 4.167 into 10 power 5 mm power 4. And moment of inertia about y axis will be db cube by 12. So that will be 50 into 40 cube by 12, that is again 2.67 into 10 power 5 mm power 4. So these two parameters we have calculated. Let us now substitute whatever we have in the formula. So let us see the total resultant bending stress will be, m is moment of inertia, m is bending moment we have calculated if 5 into 10 power 6 Newton mm multiplied by cos 30 by ixx, we got it as 4.167 into 10 power 5 multiplied by y. So let me say y as it is, plus 5 into 10 power 6 into sine 30 by iyy is 2.67 into 10 power 5 into x. So by solving, you will get it as 10.39 into y plus 9.36x. So that is what we have. Now we have to find out what are the values of y and x. So our task is to find out our task is to find out stresses at the all corners of this rectangular section. Let me name the corners as A, B, C, D, and here the load is acting, right? W, it is inclined here. Say imagine about our coordinate system. So load is in the first quadrant, so take it as plus plus. So we have plus and plus here. Just a minute, let me change the color, you will see it better. Okay, this is plus plus, so both coordinates x coordinate and y coordinate are positive here. Here x coordinate is negative, y coordinate is positive, both are negative, and here x coordinate is positive, y coordinate is negative. Okay, now the load is in the first quadrant, so I have taken like this. If the load is in this quadrant, this will be plus plus. So I will tell you finally how to calculate them. So let me take it as, so at point A, what will be the stress at point A? So at point A, what happens to small x? So small x is nothing but x bar. So for this, simply x is equal to b by 2, breadth by 2, and this is distance from the centroidal axis. That's it. Y is equal to d by 2. That is b by 2 is nothing but 40 by 2, 20 mm, and this is d by 2, depth by 2, 50 by 2, 25 mm. So x will be plus 20 and y will be minus 25. So let us substitute them here. What will we get? Let us see. So sigma a. So at sigma a is, let me substitute, take it as equation number 1, and let me substitute these values in equation 1. 10.39 into, in the place of x I will substitute plus 20, and this is 9.36 into 25. So answer will be, stress at point A will be 447 Newton per mm square approximately, right? That is positive, say that is compressive. Simply you can say that the load is acting like this, it is compressing at this point, you will face the compressive stresses over here. And sigma b, so at sigma b what happens? X value will be at b, sigma b will be, x value will be negative, that is negative 20, and y value will be positive 25. So let us substitute 10 point in the equation 1, 10.39 into, in place of y I'll substitute minus, sorry, plus 25, and in place of x 9.36 into, in place of x I'll substitute minus 20. So you will get it as 72.55 Newton per mm square, positive. This is also compressive. So at the zone uh, B, in the second quadrant, second point, you are also getting compressive stress. Sigma C. So can you tell me, both are negative here. The x value will be same, the signs will change. 10.39 into negative 20, negative 25, sorry, plus 9.36 into negative 20, that is small x. So that will be minus, similar to this, right? So you'll get minus 447 point, that's minus 447 point some 1 Newton per mm square. However, let me say 447. So that is negative tensile. So as you have seen this, that will bend like this. So above the layers will be compressed and below layers will be under tension. So we got at these two corners the compressive stress, and at this corner we got the tensile stress. So let us consider the last point, sigma d. That will be 10.39 into, what is y is negative, so let me take minus 25, plus x is positive here, so 9.36 into positive 20, so that value will be minus 72.55. That is again tensile. Please don't forget to mention what is the type of stress you are getting here. If you get it positive, that is compressive. If you get it as negative, tensile. So some textbooks it was taken as compressive stress as negative and tensile stress as positive. However, at the values, up to your imagination, up to your knowledge, up to your observation, you have to see where you will get compression, where you will get tension. When the load is acting at this point, automatically the top layers will be under compression. bottom layers will be under tension. Whatever you mention at the value is very important, whether it is compressive stress or tensile stress. So as of now, I am considering the compressive stress as positive, and wherever I get negative value, I am considering the such stress as tensile stress, right? So let us, this is what we have already calculated. So let us see how it will look. So due to the load which is acting in inclined manner at 30 degrees, 30 degrees here. So if you see, the top layers are under compression, and here the bottom layers are under tension. So whatever the value A, at A you got it as 447 Newton per mm square. At this point you will get it as 72.55, and here under tension, these 2 points are under compression and these 2 points are under tension. It is minus 44 447, and here it is minus 72.5. These two are under tensile. So sometimes the question may be asked like this: find out the maximum and minimum compressive tensile stresses for the diagram I have for the diagram shown, for the rectangular section shown in the diagram. And then in such cases you have to find out, if they ask you to find out maximum or minimum, you have to find out wherever the load is acting at that point, near to that point, and opposite point you need to find out. That's it. So here you can say plus 447, which is under compression, and here minus 447, which is we are calling it as tensile stress. So you practice one problem, load is different, I will give you in different manner. So see the question: calculate the maximum and minimum compressive stresses, compressive and tensile stresses at the for the rectangular section of simply supported beam of span 7.5 meter, which carries a load of 8 kilonewton at the center of the span. The load line is inclined at angle 25 degrees to the vertical longitudinal plane as shown in the figure, and passes through the centroid of the section. The dimensions of the section are given in the figure. So let me give the dimensions as: this is 60 mm and this is 75 mm, and these are the centroidal axis. Now the main thing how the load is given is like this: the load is acting here, the load is acting here, that is W, and here angle is 25 degrees. So you have to find out sigma maximum tensile stress, sigma T max, sigma C max, maximum tensile stress, maximum compressive stress. So here you will get maximum compression because this point is near to the loading, and here you will get maximum tensile stress opposite to that point. So when you have maximum compressive stress, the both coordinates x and y will be positive, and opposite to that both will be negative. So you just practice this, do the problem and send it to my mail id. If you already have it, that's okay. If you do not have it, that is medurimonica@gmail.com. If you have any problem, please contact me personally, or you can use this mail to clarify your doubts too. So that is the question. I am expecting more mails from you people. If you do not understand this problem, please let me know. Thanks for watching.